this is hopefully a quick demo of how to use the logic analyzer on the Tektronix MSO 2023B oscilloscope. So logic analyzer goes right in here, so if you have that port, then you're all set. You need this attachment from Tektronix. It's the P6316. Logic Pro has 16 channels. It usually comes in a case that looks like this. Alright, so first thing first, turn on the logic analyzer. Bottom left corner is your power button. And then we're going to plug this in. Common mistake is just to plug it in and feel like it's plugged in, but it's not plugged in until you hear it click. And then if you pull on it, it shouldn't come out easily. Obviously, don't pull on it too much. So on the other end, you have these two dongles for Logic Pros. You have Group 1 and Group 2. Usually just use Group 1 to start and then go to Group 2 if you have more, but really there's no difference. We're just going to use Group 1 for what we're doing today. So part of Group 1, if you look at the numbers on there, you can almost make them out. It's 0 through 7, 0 on the left and 7 on the right. And that corresponds to the pin numbers on the oscilloscope when you see it there. So on the edges are the grounds. So we've got ground and ground, and you need to make sure that those are actually hooked up to the ground on your board. So I will do that first, just to make sure we have a reference level for all our logic signals. So that's a ground pin on my board that we're going to be looking at that has display communication going back and forth. So the analyzer is turned on, but we're not looking at any signals yet, so we'll plug those in. And pin 7 is purple, and I happen to have a pin 7 that I need to look at, so it kind of like lines up pretty easily for me, but there's no real reason to align things anything other than how it makes sense for you. And grabbing pin 6 with number 6. 5 is green, so I'll plug that one in. Yellow is 4. And then pin 3 and pin 2 I also need, which are orange and red. Pin 3 and pin 2. So now I've got my ground hooked up, I've got all my logic probes hooked up. You don't need to hook up both grounds on each side. It might help for really fast signals, but in general, it's not needed. So communication is going back and forth. On my display, I just have hello scrolling across. And then on this logic analyzers, nothing's happening. So first is we've got these measurements down here. They're kind of cluttering up the screen. We don't necessarily need them right now, so I'm going to press the measure button, and then there's a remove measurement over here. So you press that, remove all measurements at the bottom by pressing this button. Looks like the screen's showing up just good enough for us to make things out. Press the menu off to ever restore the screen to nothing. So if it doesn't say run up here, then you would press this run and stop button on the far right corner, and you press it until it says run, and then this is the current signal. If it's yellow or blue, you want to press these buttons to make them go away. So you press it once to select it, and then you would press it again, and it would go away. So now I've got a clean screen. If I want to see the digital signals, I press this blue button there next to the probe we just plugged in, and I've got a list of options here. First thing to do is set your thresholds, and you want your threshold number that's selected right here to be between your logic levels. So I'm between 0 and 3.3 in the system, so I want to choose a number between those two values, usually around half. So I'm just selecting 1.5. And then we go over and we can turn on individual signals. by default, it's selected D0 for me. That's the top option. I'll just a little closer, hopefully, to make it more visible. And you use this wheel to select which one you want. I didn't use D0, so I'm going to select the display off. And I used 2, and I used 3. It will automatically shift down 4, 5, 6, and 7. So those are the ones I used. And you can see as I selected them, things showed up in the background. So it doesn't show up that great on the camera, but the ons are green and the offs are blue. And we just saw something like so we're seeing pieces of data. I only send data packets once a second, so it can be a little tough to see. But I'm seeing all my signals move. So this should zoom out more so you can see what I'm doing. This knob right here does the zoom. So here I've zoomed out quite a bit. I can see all my signals are changing state, which means that at the very least I am trying to change data on all my signals. So if for some reason one of my signals wasn't being programmed correctly, it would look more like this, that one of them is not changing state. So that's the first thing to really notice and appreciate. So that's all pretty good. And then if you turn it clockwise, you can eventually get back to something like this. This orange thing right here is the trigger, this triangle. And if I press the horizontal position, I can move that back and forth. Generally, the goal is to put that right in the middle. That will align what we call a trigger to that location. And we're going to attempt a trigger on this. So you reduce your time scale to something that seems appropriate for what you're trying to capture. So you might need to do some math, or you just do some trial and error. And you press the menu over here on the, over here on the far right. This is trigger menu. So I press that and that screen came up. And you say, all right, what do you want to trigger on? We're going to trigger on an edge, which means a rising or falling edge. But we're going to trigger on a rising or falling edge of the enable pin in this case. And enable on this board is hooked up to pin 7.2, which I hooked up to D2. So that's what we're going to trigger on. We're going to trigger on the falling edge because that's when data gets locked in for this particular display. And then I can press menu off a couple times to make that happen. So if I press, you can see it's trying to line things up perhaps a little bit, but it won't fully line things up until I press the single sequence button right here. And then it will just grab a single data capture and it'll put the rising edge at, again, that triangle location. So I was pretty close with my estimate, but I can expand things out just a little bit to see some data. And perhaps put my rising edge right there. When you zoom in, the fidelity of the data is lost a little bit. It's not as pristine as it could be if I just did another capture. So I press single sequence again, and it'll grab a new data set that is now at that better time resolution instead of just a zoomed in copy. So from here, we have an instruction right over on the far left, and then some data rates right here. And it's sending a piece of data. So if you want to, you can zoom in with this knob here, or you can just zoom in manually here. Pin 2 right here is my enable pin. It locks in a piece of data when you see a falling edge. So you can use some cursors to figure out perhaps what the data is. The cursors are way far over there, but you can align right here and say, all right, the way this sends data is through 4 bits at a time, so it's sending a 0010 because it's low, 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 high, low, and then the next pulse where enable going low is when it locks in the data, it's 0000. and that is the instruction to move the cursor right there. So you have to decode that, make sure that's the message you wanted to send, but that's how you go in and look at things. Any data that's transitioning outside of that enable going low doesn't matter. It's only going to send and acknowledge data when your enable goes low. So we'll grab one more thing, and we'll use the zoom this time to grab more data and zoom in. So you press the zoom button, or you just start turning this knob. Either one is really fine. And then the original waveform is at the top here. The zoomed in waveform is down here. And you can move like back and forth using this bigger knob around the outside. And you can zoom in with the knob in the middle. So that allows me to go through and like have a zoomed in copy, but still maintaining the original full data set. So here you see a little glitch of data, like data changing, but it changes back, and it changes back before the enable goes low. So that piece of data is not actually needed or recorded by the display. Again, you can use your cursors to go out and like align things to make sure you're looking at the data at the exact right time. So here we're recording a 0110 at this location. And then enable going low again, that's that last line right here would be a 0101. And that likely decodes to an ASCII character because that's what I'm sending right now. But that is how you set things up. Let's see anything beyond that that is perhaps important. I will take the zoom off. So this changes your time frame right here, this thing. This changes the position on the screen, this knob up here. We don't use those for this particular purpose. These are the two cursor knobs. So you have a second cursor and first cursor, as long as your cursor button is lit. And again, this is the knob to the button to enable and disable certain individual pins on your logic analyzer. Trigger menu is useful to capture an individual time. Should you not need the trigger, like data is always continuously flowing, you can press the run stop, and when data shows up on the screen, you just press stop. And maybe you get the exact right thing just by doing that, like I just did. So you can just press run stop and just try to get it at the right time if you want to. Perfectly fine to do that. But this is definitely the more advanced thing, using the trigger button and triggering on a data transition that you care about. Okay, hopefully that helped.